Hey, oh, sorry. Y'all, it's like just a fun house in my brain. Okay. Okay, so we've done z-test, which are for large samples. We've done t-test, which are for small samples. And now we're going to do z-test for a proportion. A z-test for a proportion is when um, you're, okay, so the z and t-test are for the word sounds like Z and T. The Z and T test, regular Z and T tests, are for quantitative data, like things with numbers. And then the Z test for a proportion is for qualitative data, like would you rather go back in time or would you rather see into the future? So qualitative is category. And then quantitative is numbers. All right, so Z test for proportion, exact same steps. They're going to give us the alpha. This time we're going to do z-test, traditional or p-value. And the z-test uses the exact same values as the z-test for proportion uses the exact same values for a z-test. That chart, and actually let's get that chart available in just a minute. I'll get a copy of it for you. Here's our chart, or we can do the p-value, and then we'll compute it on the calculator. And then we're going to compare and summarize our results. So same steps. All right, we can use a formula and do it by hand. I'm kind of a big proponent of technology, so I'm not going to do that. Okay, remember, it's a binomial experiment. It's a yes or a no. You know, it's not how many energy drinks did you have today or this week. It's did you have an energy drink this week, yes or no? All right, so same thing. We're going to go to stat, go over to tests, and then click on one proportion because we're only a little intro to stats class, and so we're just comparing one proportion. And then the problem will give us that information. You decide if it's two-tailed, one-tailed, right or left, and then you'll calculate and it will pop up some answers. And then the most important part is analyze. All right, so let's write down some information. A researcher claims, based on the information from the Center of Disease Control, 17% of young people are obese. To test this claim, she randomly selects 200 and found that 42 were obese. So 42, 200. At alpha equals 0.05, is there enough evidence to reject the claim? All right, so I should have added some sort of sentence that said, a researcher claims that, let's go with more than 17%. All right, so that's the hypothesis and the null. All right, when we go to stat, test, number 5. All right, and so we're just going to type in what they gave us. They said it was 0.17, and then x was 42, and then n was 200, and we're going to go to the right. Make sure yours matches mine, and then push calculate. And so these numbers, if yours is relatively close, fabulous. If you're way off, you type something wrong. All right, so double check. Sorry, do I look like a giraffe or something with a chewing my gum. All right, so Z equals 1.5. P is 0.066. P hat. So 42 over 200 is 0.21, by the way. All right. Let's hang on one second. All right. So I wanted to go. I went and grabbed the chart. This thing right here. It's something I just like summarized from the book. Maybe I should make a prettier version, but here it is nevertheless. All right, and these are the critical values, CV, critical values, that we're going to compare that Z to. All right, right here's the problem. Where alpha equals 0.05 and it points to the right. All right, right 0.05, so we get 1.65. Here we are. 1, 2, 3, 1, 2, 3. 1.65 is in between 1 and 2. All right, there we are. And this 1.5 is right there. So it's in the white, and if it's in the white, you accept it. So we're going to accept the null. Okay, we're going to accept the whole. So we're going to accept the fact that the it is 17%. What if we did this problem and I said, okay, alpha is 0.10 or 0.01. Let's do that and see what we get for our t. I mean for our comparison. So 0.1, 0.01, and it's to the right. Let's go see what those numbers are. Okay, to the right, 0.1 is 1.26, 0.01 is 2.33. 1.28, 2.33, 1.28, 2.33. I'm already forgot it. I already forgot it. Gosh darn. All right, let's do one number at a time. 0.1, 1.28. 0.1. CV is 1.28. 0.01, 2.32. All right, so let's do 1, 2, 3, 1, 2, 3. All right, and so we're still going to use this. All right, 1.28 like there. 28, and then all this is shaded. All right, and we're going to compare 1.5 to it. 1.5 happens a little closer to the number 2, and so it's in the shading. So in this case, we would reject the whole because it's in the shading, it's in the dark. All right, let's do, what if it said alpha is 0.01? So as you can tell, I'm an amazing artist, so you don't, it's okay if you're jealous of my abilities, really. All right, 2.33 is right after 2. So it's like right there. All right, and then we're comparing 1.5. All right, so 1.5 happens between 1 and 2. So it's right there, and it's also in the white. This guy was. So when it's in the white, we accept the whole. I don't. Okay. All right, so it's amazing. So this says, hey, when I am, what's this, alpha? When I'm 95% confident I'm right and 5% confident I'm wrong, I'm going to accept the fact that it's 17%. When I am 99% confident that I'm right, 1% confident that I'm wrong, I'm also going to accept that it's 17%. I'm 90% confident and 10% I think I'm going to be wrong. I'm actually going to reject it. All right, it's like saying, you know, your girlfriend's coming to the house, your parents aren't home yet, and then your parents are like, don't do it, and you're like, okay, how confident am I that I'm not gonna get in trouble? Okay, are you 99% confident you're gonna not get in trouble? Probably not. Okay, are you like 90% confident? Maybe. Okay, don't do that. And you're older now, so I guess it doesn't really matter. All right, let's do another problem. The crime survey study stated that 23% of women were gun owners. The researcher believes it's less than 23. So this is the null. This is the alternative. He randomly selects 100 people, and he finds that 0.11 of gun owners are women. And so this is, we need to like change that because our calculator needs us to have x. And so x is going to be 0.11 times 100. There's a fly, and I'm not a good fly killer. Slow. All right, so 0.11 times 100 is 11. All right, so I'm going to go to stat, test, number 5, and then for p, I'm going to put 0.23, x, I'm going to put 11, and I'm going to put 100, and this is less than. So let's make sure that that's covered. All right, there we go. I'm going to write that information down. 2.85 equals 0.002. Let's do the p-value. I know it doesn't say it, but let's pretend like I wrote, hey, do the p-value A. Okay, so the p-value A, remember, was you compare p and you compare alpha. All right, and p, we got 0.002. Alpha is 0.01. And this guy's bigger. And so that guy's bigger, and so we're going to accept so we're going to accept the fact that it equals 0.23. What if, okay, I said, let's do alpha at 0.5. So like I'm 95% sure I'm right. 95% sure I'm right, 5% I think I'm going to be wrong. Versus this guy was, I'm 99% sure I'm right, I'm 1% sure I'm going to be wrong. All right, so then we would compare 0.02 to 0.05. And it goes this way. And so when it goes less than, then you reject. So we would reject that it was equal to 0.23 and that we would actually think it's less than. All right, I'm going to stop the video and finish this up in the next video.